Hey guys, welcome back to my channel. Today we are creating a delicious chocolate swirl effect. So grab your virtual tool and let's get started. First we are going to create a circle. So let's drop down a circle node. We will set the orient to XY and the division to 29. Next let's scale it a bit. Set the scale to 5. Now we need to extract the center of our circle. To do this, we will use the extract centroid node. Make sure to set it run over primitives. This will give us a point right at the center of our circle. Next we will take a normals of our circle. Connect a normal node to this circle. And then we will connect this to the grid node. Let's scatter some points on a grid. Add a scatter nodes and connected it to the grid. This will give us a random distribution of points to work with. Next we will use attribute angle to set the velocity of our points. Connect the scatter node to the first input and the centroid point to the second input and rename the velocity. Now create a vector called pos. Get the position from the second input. Use point node. Geometry handle will be 1. Input data will be p. Run on point number. Calculate the direction vector v@dir equal to normalize pos minus @p. Calculating the cross products of normals and direction. v@ndir equal to cross @n comma v@dir. We will get the normal direction. @cd equal to ch ramp. Ramp name will be cd. Using feed length pos minus @p 0 10 0 1. This will set color based on distance. v equal to v@ndir. Multiply with 0.7. Multiply with @cd plus noise @p. Multiply with 0.02 plus v@dir. Multiply with 0.02. Set the noise v@o noise. This will combine the vector from velocity. Now just hit the compiler. Now we can control the velocity through color ramp. Attach the null and rename as well. Now take one more scattering point node and increase the density. Now let's bring a pop network to add some dynamics. Attach the velocity output from the attribute wrangler to the second input of the pop network and connect the new scatter node to the first input. Go inside the pop network where we want to set up the emission. Set the emission type to all points. Turn off the guide. In the burst tab, in the activation type, use the expression $FF == 1. Control when the emission occurs. This will only emit on first frame. Add a geometry warp. In geometry warp, from input 2, set it to the context of the geometry second input that we want to use. Inside the geometry warp, press the tab key and type PC filter. Now create PC open. Connect the output to the file input of the PC open. Then connect the P to the position input. Then connect the blue handles PC open to PC filter. Here vector will be V and connect the output V. Right click on PC open, hoverboard on wax option and create input parameter. Set the search radius 50. Numbers of point will be 19. If you want to add more noise, use the pop force node. Set the amplitude to 0.3. Let's go to object mode. In velocity, we can set the radius of this swirl effect. Next, take a point deform node and connect it to the last input of the pop network. Then copy and paste the circle node. After that, add a remesh node and set the target size 0.03. Connect the output of the remesh node to the first input of the point deform node. Finally, take the scatter node and connect it to the second input of the point deform node. Next will be our reverse. Sometimes this thing will occur. If this happens, to fix this stretch, we can use delta mask. This technique will help to correct the issue of layer stretching. Wingardium Leviosa. Here we can see that it's gone. This is amazing node that I use to fix these types of problems. Now it's color time. After the remesh node, use Wrangler node to create integer called number of segment and set it to value 8. This represents the number of segment for our color wheel. Next, create a float called angle. Use atang2 function to determine the inverse tangent value between @p.z @p.x. This will calculate the angles of points. Then create a float called index. Index equal to floor angle plus pi value. Then divide by 2 and multiply with measure of pi. Divide by number of segments. This will determine the segmented index based on the calculated angles. Create a colors vector array. Next, define the colors black and white using vector array equal to set black value 000 and set the white value 111. Finally, assign an alternative color based on the index. So iterate cd equal to colors index modulus 2. This will alternative color between black and white based on the calculated index. Here we add. To blur the sharp edges and achieve a more natural look, use attribute blur and adjust the parameter as needed. Make sure the attribute you are work with is set to be iterate cd. To set the color, use color nodes. Color type range from attributes and color will be cd. Set color whatever you like. This is pretty much it. Thank you for watching. I hope you see you again.